This is another air data computer. This one is very big. The depth of this thing is about 50 inches. The height 7.5 inches, and the width about 3.5 inches. So this is a modern air data computer. You can see the hidden plate. Make a small zoom here. Okay, so you have the reference of the standard for the firmware here, TO178B, level B. So this was manufactured by Smith. The reference of this thing is here, 54F8D2-3. So on the front there is a selector in order to activate the self-test, I guess. So we have the results of the self-test here. So on the front we have the two pressure inlets for static and pitot pressures. On the rear of this thing you have two connectors. So let's open this thing to see what is inside. Here we are. Okay, so we have 5 electronic boards, a power supply in the middle. Here, there is nothing on the rear of this instrument. There is a relay on the back. So let's remove the other side. Okay, the sensors are located on this area here. It is difficult to see. I don't know the technology of these pressure sensors. So first, let's have a look on the electronic boards. Okay, so this is very nice. So we have several logic ICs on this board. '54HC series. So we have some counters here. First, we have AND gates here, D flip-flop, etc. This one I don't know. LA 120 dB. And this is probably ICs for ARINC 429 interface. I'm not sure. And this metal can ICs here. Difficult to read. This is a military part. John TX 2N6849. There is a conformal coating on the board. And we can see also these metallic bars which are just below the ICs, probably for heat dissipation. Actually it is written on this thing, ARINC, so effectively this is the ARINC interface board. I didn't see the date code, so the date code of this thing is 98. 98 for most of the parts. 98 also for this one. Okay, so we have some bodges on this board, but they are secured with a conformal coating. So this board, normally it is written micro. So this is obviously the microprocessor board. You can see the oscillator here with a very serious design with an offset of plus 0.2 Hz. So the dead code is also 98. Every part has a dead code of 98, it seems. So this is the MT70-133, and the processor is here. It's the Intel ATC86, a 16 bits microprocessor, a classic. So this is probably the static RAM, 6116. So we have 82C54. I don't remember, it was a classic interface in a PC computer 30 years ago. I don't know, it is maybe a timer. I'm not sure. So we have here an 8028C16. So this is a 2K EEPROM memory. And the code is embedded into this 2 EEPROM here. As it is a 16 bits bus, we need 2 EEPROM for the complete 16 bit. This is a dual-sided assembly. You have some decoupling capacitors and a few resistors on this side. 2 bodges also. So I didn't see the reference, so this I cannot synchro 1. So this is probably to provide outputs in order to be compatible with the synchro resolvers. You can see that we have several DACs. DAC 8221. We have also some analog switches here, DG508. So these are multiplexer 1 to 8. This is an OP400, a quad op amp. There is another analog switch here, DG302. Another one here. So you have several analog switches. It's another one. Then you have also op amp and some logic ICs here. Some buffers, latches here. And this part is a VQ100P or 1000 or 100. Cannot read. The transistors are referenced to N4239, so there is maybe an NPN and a PNP, 4236 and 4231. It's a nice board, very well designed, I think. There are 2 relays also here, I didn't see. And this thing is probably a PAL or something like that, in order to have a decoding for the various addresses. Okay, so this board is a resolver actually. So we have two synchro boards, synchro 1 and the last one is synchro 2. You cannot see here, but it is synchro 2, so I think this is the same board probably than the other one. We will see. So there are also a few budgies here and here. This is a multi-layer board also. So this is an AD574, maybe an ADC, but I'm not sure. There are some logic ICs here, NAND gates, etc. X inverters here, and the AND gate, HC08 here. We have a low noise op amp, OP07 here. We have several low noise op amps actually, we have others here. We have this small, I cannot read, it is very small. Maybe a voltage reference or something like that. It is maybe upside down. Okay, so this is difficult to read. So this is a LM113. This is maybe a voltage regulator or a small voltage reference. And this thing is a PM156. This is maybe an op amp. There are very nice parts on this thing. So we have here a metal foil resistor, very high accuracy, you can see, 0.005%. This is a 680 ohms. Here we have another analog multiplexer, 8 inputs to 1 output, an ADG 508, low leakage current. We have also several analog switches. We have another also DG509. So I think this is also a multiplexer. Have another one here. And we have several resistors, accurate, 0.1%. Some trimmers here for adjustment. And so this is the same board than the other one. So this permits to drive 4 synchros, exactly the same. Okay, and we have the power supply in the middle. I think it is also inserted. We can remove this thing. This one is maybe secured. I think we need to unscrew these 2 little screws here. There's maybe something in order to secure the power supply in place. Okay. So let's see this locking system. So effectively, this permits to lock the board. On the bottom PCB, there are several, several coils and some ICs also. And we have this Datatronic, so this is maybe a small DC-DC converter, I'm not sure. It is written LM116, 1165, sorry. Dead code 98 also. So let's have a look on the power supply. This is a very big capacitor. I have never seen a capacitor with such a size. So I cannot read the value, but the voltage rating is 200 volts. So this capacitor is glued, as you can see, to the PCB. It's a kind of silicone, yes. There is a common mode choke here. So the input voltage is here. There is another choke here. So this is for the filtering of the DC voltage. This is a very nice power supply. There is the main PCB and there is this daughter board here. You can see that we have several mini-melt resistors. And this board will be difficult to remove because, as you can see, there is a conformal coating. And the conformal coating is also applied, of course, on the screws here. Maybe it is possible with pliers. Okay. So there are very few parts on this board. Only LM124 quad op-amps. We have also an LM139. So this is a part with 4 comparators. Another one and another one here. This is just a board for comparison. And there are also a few transistors. So you can see also the assembly of these transistors, or probably transistors. I cannot see it, it's very strange. Because I think they did this thing for power dissipation. As you can see, so there is this small spring here, which permits to hold this transistor. So there are two N. I cannot read. The spring is just in the middle here also, so it is difficult to see. There is a 6 and 02 on the end. So this is a 2N6802. It's probably the same here, but these two guys here, I don't know because the marking is not on the top of this part. And you can see that the terminals are soldered like this on the PCB. And so here we have a CD4047. I don't know if it is not an oscillator or something like that, but not sure. Not sure if I can remove these screws also. There are 6 screws to remove this top PCB. Let's do it. It's now or never. We have one CD4047, we have already seen this part, and this is another one, CD4047. We have some passive parts and Also some transistors we have already seen. On the other side of this PCB, on this side there is nothing exciting. Coils, diodes, capacitors and stuff like that. So there are several capacitors from WIMA. This big pink capacitor is a 4.7 microfarad, 63 volts, polycarbonate maybe. So this is from Hero. Okay, I will reassemble this power supply and we will take a look on the sensors. This is the most interesting thing. Let's take a look on the sensors now. The sensors are here. They are more or less identical and they are screwed on the bottom side here. The die cast is designed in order to have directly the pressures on the sensor side. So let's remove the connectors first. So this is a flat flex PCB with a stiffener here. So let's remove the other one. So let's have a look on this beautiful sensor. The input pressure is here. They are more or less identical, probably. So one permits the measurement of the pitot pressure, and the second one for the static pressure. So the difference between the pitot pressure and the static pressure is performed by firmware. And we can see that they are the same actually. Probably they can measure positive or negative pressure, each of them. I don't know if there is a reference somewhere. There are some indications here, except serial number. You can see that the reference of these sensors are identical. FRD 186-2. So I don't know the technology of these sensors. We have here a flex PCB also made with Kapton. So we have two terminals here, here, and here also. There are also two terminals on the back here. I didn't see it. There is a microcontroller or something. There is a sticker on this part in order to identify firmware or something like that. So let's remove this board. It can be interesting to see the parts on this board. There are a lot of wires which are connected from this part to the connector here. So let's remove this board. This one is very small. Okay, but there is a nut, so I will remove this one instead. Okay. So this is an AMD brand, so this is maybe just an EEPROM. Yeah, so this is maybe an EEPROM which contains some adjustment parameters, some calibration coefficient, because it seems that there is nothing connected from this EEPROM to the rest of the board. There is no track on this side of the PCB. There are only connections to this part here. So let's have a look on this part. Okay, so you can see that this is effectively an EEPROM, a 2732. Probably several calibration datas are programmed into this EEPROM. This EEPROM is soldered, so it is not possible to read the values, unfortunately. Otherwise, there are several op-amps, 101, the transistor, the classic 2222. There is another 101 here, another one. Probably the main input-output are these 5 terminals here, and probably also these terminals here. Maybe it can be interesting to do the reverse of this thing. So maybe with this with the schematics, it can be possible to use this sensor. It is not obvious to work like this. And I just need to desolder this flat flex here. We can see the number of terminals for the sensor. So there are normally 5 or maybe 6. Maybe 6 terminals. You can see that this EEPROM, the date code is 1983. So it is not a recent part. So I cannot see the date code also of the ICs. They are maybe the same, but I don't know, I cannot read. I will desolder all the wires and I will start the reverse engineering of this small PCB. And after it can be possible to perform some tests with this sensor. We will see. So this will be done in next video, I think, because otherwise this video will be too long. Thanks for watching and see you next time. Bye.